Okay, my friends, this is part 2. I have just a little bit to go on 7.3, right? So this one here looks like that doesn't have a common denominator, right? It's asking us to subtract. The denominators aren't the same. It's going to have to factor those denominators. They're not easy enough for me to factor right there, so maybe I'll factor them right up here. And so let's see here, not a common factor for all of them. 2x times x is the only possibility. 1 times 6 and 2 times 3. I know the signs are both positive though. Because since this is a positive, that means they're the same. And this says, yeah, they're both just like me. So they're both positive. So let's see, we want to add up to 5. 6 is already bigger than 5, so we can't use the 1 and the 6. So it must be, if it's going to factor, that it's going to be somehow 2x and x, plus and a plus, and we're going to put in the 2 and the 3. I wrote that down wrong. Do you see that? This was a 3. I don't know what I was thinking. But I picked up this denominator here and put a 6 because of that denominator there, I'm sure. And I was now working on it and thinking, this doesn't factor. So let's see here. 1 and 3 is the only possibility, and I want to make 5. And I don't want the 3 to multiply with the 2, because if it does, that'll make 6, and that'll be too big. So I'm going to put the 3 here and the 1 there. And I can check it to make sure. So on the outer I get 2x, on the inner that's positive, on the inner I get positive 3x, and when I add those together I get 5x. So boom, boom, boom. So here I have 5x plus 3 divided by 2x plus 3 times x plus 1. And actually, if that reduced, it'd be okay for me to reduce it, but it doesn't. So that's a binomial, 5x plus 3, and it's not the same as either one of those binomials. Now I'm going to factor the other piece here. So the other piece here, 2x squared plus 7x plus 6. So 2x times x, 1 times 6, 2 times 3. And I know that the signs are both positive for the same reason they were on the other one. And let me think, I'm trying to make 7 in the center. So I'm thinking, gosh, if I could make 2 times 4, 2 times 2 would make 4. And then that would leave me with a 3 there. So I'm kind of piecing it together. I was kind of thinking, well, the 6 is just too big to the 7. Almost already there. And then I would have the other stuff to multiply, the 2, right? And that's not going to work. So 2x and x and x, and I wanted this to multiply with the 2 to make 4x, and I wanted this to multiply with right there, so that's positive 3x, and boom, boom, I made 7. So you do get better at it when you practice it. If you don't practice it, you're not going to get better at it. That's what it takes to get better at it, is to practice. And so 3x minus 9. Now I'm working on getting a common denominator, now that I've got those denominators factored. And I'm thinking to myself, well, what is the common denominator? Well, they have in common a 2x plus 3. So that's part of the common denominator, but no need to worry about it. And this one has an x plus 1, which this one does not, so the common denominator needs an x plus 1. And this one has an x plus 2, which this one does not, so it needs an x plus 2. So there's the common denominator, and I want to make both denominators look just like that. So this denominator right here is missing the x plus 2. So we're going to x plus 2 it, top and bottom. So right up here, multiply by x plus 2, and in the bottom, multiply by x plus 2. And in the next one, it's missing the x plus 1. So I'm going to multiply top and bottom by x plus 1, because remember, that's the same as multiplying this fraction by 1, which leaves it unchanged. So now the denominators are the same. They have the same 3 pieces. The denominators do. Order doesn't matter. And all I have to do is I have to multiply this together and subtract it from that. And so I'm going to do the multiplying first. That's going to be FOIL. And so just multiplying this part together is going to be 5x squared, right, when I multiply here using FOIL, plus 10x plus 3x plus 6. And I'm going to go ahead and combine the like terms, and then I'll write it over the common denominator. So that's 5x squared plus 13x plus 6 over the common denominator. Those 3 binomials, imagine them there. 2x plus 3, x plus 1, x plus 2, minus, and we're going to have those 3 binomials here too. And so I'm going to multiply that together. I'm putting my finger over the minus because I have it right here, and I'm just going to FOIL that together. So that's going to be 3x squared, there times there, plus 3x minus 9x minus 9. And when I combine like terms, I have 3x squared minus 6x minus 9. And remember that parentheses are right here and right here. They're implied. And so I have to distribute that negative in order to subtract. In here, I still have just the 2x plus 3, the x plus 1, the x plus 2, but I'm ignoring it. So that's the reason I don't care if I really write it there. I am filling in the blank here, but I mean, as far as it's just down there, and my focus right now is on doing that subtraction. And the first thing that you do to do that subtraction is you distribute the negative. So this is going to be a negative times a positive is a negative 3x squared. A negative times a negative is a positive 6x. A negative times a negative is a positive 9. All divided by the common denominator, which is those 3 binomials. The 2x plus 3, the x plus 1, and the x plus 2 in any order. And now I'm on combine like terms. 5x squared, take away 3x squared is 2x squared. 13x plus 6x is 19x. And 6 plus 9 is 15. All over the common denominator. After you add those together or subtract them, since we distributed the negative, then we ended up combining like terms, which was adding. After you do that, then you have to factor. And so you factor the numerator, and you send praises because the denominator is already factored. I don't have to do anything to it. So there I am now trying to factor 2x squared plus 19x plus 15. So it's a binomial that doesn't have anything in common other than 1. So it's 2x times x. It could be 1 times 15, or it could be 3 times 5. And I want to make 19 there in the center. Makes me want to go back with my fingers and make sure that 13 plus 6 is 19. So let's think here how that could work. And I don't think it will, right? If I use the 1 and 15, 2x and x here, positives, the 15 could go here, but then that's not going to be big enough to make 19, because you're going to get 15 times x is 15x plus 2x, that's 17x. And so that didn't work. And so then we're on, well, so that didn't work, right? If I move the 1 here and the 15 there, that would make 30, and that's too big. So that didn't work. And then 2x and x, and the 3 and the 5, plus and a plus. If I put the 3 here, that's 6. And if I put the 5 there, so here makes 6, putting the 5 there makes 5, and 5 and 6 is not 19, 5 and 6 is 11. So if I put the 3 here and the 5 there, then this is 10, and 3 is 13. So it doesn't factor. So this is the answer. So I tried to reduce it, but it doesn't always reduce. And so that's kind of the story on that problem. And my friends, I will upload the lab for you to do the daily incentive points. DIP is what I call those when I'm abbreviating, but so many people were asking what does DIP mean, that I put daily incentive points on the next, or daily incentive, because that's what I usually call it, I guess, in class when I'm talking. And so I hope that you're working hard. I'm going to try to have some more office hours tomorrow, and that worked out well today. I thought it had about 7 people come, so that's pretty good. Some people were in and out, and a couple people stayed the whole time. It's wonderful. Okay, talk to you guys later. I hope that you're doing well. Bye-bye.